Good evening. This is my Physics 2212 Lab 2 video lab report. Now, the purpose of this lab was to understand the concept of charge and use this understanding to approximate figures for modeling in 3D. Some of the fundamental principles used in this lab is Coulomb's law, which gives us the force of 2-point charges acting on one another. Electric field, Newton's second law, which is force is equal to mass times acceleration, which leads us to force due to gravity, which is mass times gravity. Newton's third law, which states that for every action there's an equal and opposite reaction. The constants used in this equation include the electrostatic force and electron charge. Some of the assumptions made in this lab is that all pieces of tape have the same charge. Charge is distributed uniformly on the surface of the tape. Tape can be treated as a point charge as a result of that, and that air resistance is negligible. Some experimental background on this lab is that objects have the potential to amass an extra charge, either negative or positive, through actions such as friction, separation, or contact with other objects, which involve the transfer of charged ions or electrons. Determining the surplus charge on a charged strip of transparent tape can be challenging, as it can vary anywhere from the charge of a single electron to roughly the charge equivalent to a mole. This wide range presents a considerable spectrum of possibilities. Performing this straightforward experiment enables an approximation of the excess charge present on the tape within a magnitude order, granting insight into the usual range of surplus charge in everyday objects. It is of the utmost importance to maintain proper experimental techniques, especially when handling and preparing materials, and to exclusively touch a charged piece of tape by its extremities. Some of the initial conditions of this lab were used from Lab 1, which include the length of the tape, the width of the tape, the distance between the tape that we observed, and the mass of the tape. The primary system in this experiment, similar to Experiment 1, is the suspended tape B and the surroundings being tape A. The results for Lab 2 found that the magnitude of the electric force is 4.739 times 10 to the negative fifth. The magnitude of the gravitational force is 1.962 times 10 to the negative 6. The experimental procedure is shown as follows. Step 1, which is to suspend a piece of tape between two objects and begin bringing a piece of tape that has been charged closer to that object. Step 2 is to observe the distance at the instant the piece of the suspended tape begins to move, and that would be your separation distance. Step 3 is to treat the pieces of tape as a point charge and compute data for use in glow script. This is the code where the computational model is shown on the left, and the code itself, which was given as a template in Lab Manual 2, is shown on the right. Only alterations made to the code were the mass of tape, which we pulled from our experiment Lab 1, and the estimated charge on one tape, which was computed in Lab 1. And this is the subsequent lines of code that weren't shown in that first slide. One of the questions raised is that what if you had modeled each of your tapes as a single point charge like in the previous lab? We were asked to compare the estimated value of the charge when you use experimental data to produce a point charge model to the value that we got with our line charge model. And when computed, this found that the point charge was roughly equivalent to 2.635 times 10 to the negative 8 coulombs versus our previous lab's 1.633 times 10 to the negative 8 coulombs. Now, a question raised because of that is, why do these estimates differ, and which value is more likely to be closer to the real value and why? Representing tapes as line charges enables us to make calculations and observations that more closely align with real-world scenarios. This approach also enhances our ability to accurately estimate the quantity of charge present on the tape. So the line charge model is more likely to be closer to the real value. Some of the expectations we had in this lab was that the pieces of tape would repel each other as they have similar charges. This is due to the fact that like charges repel and opposites attract, and we observed that the pieces of tape repelled each other, and they were also attracted to the positively charged pen, which allowed us to deduce that they were negatively charged, the pieces of tape. Now, some possible sources of error in this lab is air resistance due to a non-vacuum environment, anything from air conditioning to just air displaced from hand or body movement throughout the lab. An excess charge due to non-ideal handling, which your hands may have had a charge,